Today we're going to be testing the chemistry of mouthwash.
We're going to go over different chemicals in mouthwashes that make it effective. Then we're going to go over a lab experiment that we did to test the different effectiveness of alcohol versus non-alcohol mouthwashes. And then we'll go over our data and results.
Okay, so what are mouthwashes? They're an oral hygiene element that are help to keep our teeth healthy by preventing oral diseases, and they also fight tooth problems from sugary foods. They rinse the teeth, gums, and mouth, and people use it to get rid of bad breath and tooth decay.
So what is the difference between non-alcoholic mouthwashes and alcoholic mouthwashes? So basically non-alcoholic mouthwashes don't use alcohol. Instead, they use other chemicals such as like cytopyridium chloride and chlorhexene glucinate and fluoride. And basically these are alternative chemicals that help deal with bacteria without alcohol. But mouthwashes with alcohol use it because they believe they are better at killing bacteria. And it can also be used as a carrier agent for essential oils, which are important to helping the mouthwashes functionate.
Okay, so one of the first chemical structures in non-alcoholic mouthwashes is cytopyridium fluoride. It's a ammonium compound with nitrogen atoms are positively charged and they're bound to 4 organic groups. It is positively charged and can interact with negatively charged fluoride ions, and they have an amphiphilic nature and hydrophobic and hydrophilic regions. This allows it to form micelles, which can encapsulate dirt and bacteria.
So our next chemical is sodium fluoride, and basically this is used as an ionic compound. And the importance of sodium fluoride is that it can be used as a fluoropatide. And basically this helps make the teeth more resistant towards like acids and decay, and this helps make the teeth stronger and prevent cavities.
Okay, so another chemical structure in non-alcoholic mouthwashes is glycerin. They have 3 hydroxyl groups, which makes it possible to form hydrogen bonds and allows it for viscosity and high boiling point. It is also a humescent, which helps the mouthwash retain moisture and prevent dryness. It's also important to dissolve active ingredients.
So our next chemical is sorbitol, and basically this is used as a polyol, and as a humectant. It can basically be used as a sweetener in mouthwashes. This helps make the mouthwash taste better. It can also help stabilize the mouthwash solution. And this also is important because it helps increase the life of the mouthwash, make it last longer.
So next we have chemical structures in alcoholic mouthwashes. So the first one is ethanol, which has a tetrahedral geometry with sp3 hybridization. It is also polar and has a polar OH bond. The polarity is important because it makes the mouthwash better at disrupting microbial cell membranes, which helps the microbial action. This is important because it allows the ethanol to kill and inhibit the growth of bacteria quickly, and is also used to dissolve active ingredients, making it more effective.
All right, our next chemical is thymol, and this is important because it helps destabilize microbial cell membranes. It is attached to a benzene ring, which is important as it helps disrupt the membranes due to its interactions with the microbial membranes. And also, it affects the kinetics and equilibrium of the microbial cell processes. By making it imbalanced and not having equilibrium, it makes it harder for the microbes to survive. And by slowing down the kinetics, it halts the growth and reproduction of the microbes.
Okay, next we have eucalyptus, which is has organic synthesis concepts and properties of ethers. It also includes isoosm, which helps interact with other compounds. It's a silic ether, which helps it interact with other components and increases stability, which makes dipole-dipole interactions and helps it solubilize in mouthwash formations.
Next, we have methyl salicylate. This is basically derived from esterification of the salicylic acid in methanol. This helps the mouthwashes retain its beneficial properties that make it work. It also makes this chemical also makes it easier to incorporate mouthwash formulations. The aromatic hydroxyl group can do hydrogen bonding, and this is important as it affects the solubility of the mouthwash. This chemical gives it more flavor, and it also helps reduce the pains that it could create in the gums.
And now we have benzoic acid. It's a weak acid that ionizes in water. It is involved in pH and pKa calculations as is the carboxylic acid. It's important to help the mouthwash have an optimal pH level for oral health. It needs a mildly acidic pH to inhibit the growth of bacteria without being too harmful to oral tissues.
All right, so on this slide, we have some explanations of how mouthwash chemistry can be used and some of the stuff we studied in AP chemistry. Like, for example, in thermodynamics, like these mouthwash ingredients interact with bacteria. And because when this happens, there are often enthalpy changes, such as exothermic reactions that release heat. This is important because it helps with the antibacterial action. It will allow it to occur more spontaneously and will be more effective in killing bacteria.
Mouthwash chemistry can also be used in equilibrium. Mouthwashes have a specific pH which makes it more effective for antibacterial activity, and having a equilibrium between hydrogen ions and other components will affect when the equilibrium and distance states are involved, and also the pH are carefully balanced to maintain equilibrium, and then there's also dynamic equilibrium as well.
Last, we have chromatography and spectroscopy. So basically, liquid chromatography can be used to separate and quantify the ingredients in the mouthwashes. It helps make the mouthwashes maintain its high quality. Gas chromatography can be used to detect possible contamination in the mouthwashes, basically making the mouthwashes more safe.
Okay, so the purpose of the lab is to test which brand of mouthwash is more effective in killing bacterial Listerin, which is alcoholic, or Crest, which is non-alcoholic.
So our hypothesis is that alcoholic mouthwashes will cause less bacterial growth than non-alcoholic mouthwashes. There's us.
So to test this experiment, we're going to use different mouthwashes, and involves using petri dishes to measure the growth and decay of bacteria, and the samples placed in the petri dishes. We'll put one sample in each petri dish, and we'll also have 2 control petri dishes as well.
So what materials do we use for this experiment? Basically, the essential materials for the petri dishes, obviously the mouthwashes are going to be used, the bacteria samples which we created, you'll see that in the lab video later. We also use an incubator to store the bacterial samples, and also most importantly, we had safety gear on. As you can see, Kevin's wearing a lab coat. That's very important.
Okay, so first you gotta gather materials and sterilize in the environment. And then get 2 test subjects and 4 petri dishes. Either they could be 2 agar-bot or 2 laurier-bot. And using a swab of cotton, get each test subject to take an oil sample from mouth and spread it to 2 petri dishes. This is the control. Also, get the 2 test subjects to take one of the mouthwashes, make the amount of mouthwash equal to each other, and make them switch each of them in the mouth for 30 seconds. And use another cotton swab to spread the mouthwash samples onto the other 2 petri dishes, label the dishes with the mouthwash name. Finally, you use parafilm to seal the dishes, and after 3 days, you check on the petri dishes that were in the incubator that was set at 37 degrees.
All right, so basically this is our data after testing from Friday to Monday. We saw much bacteria samples. As you can see, our experiment was effective. We can see that one is labeled as a control sample. The red ones were used for Crest, which Emily Colmar did, and then Jane did the alcoholic mouthwashes, and as you can see, that is the results. What was the explanation and reasoning of our results?
The alcoholic mouthwashes were more effective because they killed more colonies of bacteria. They killed around 80% of the big colonies and broke down many of the other colonies at a high rate than the Crest did. Compared to the control group, the Crest was very similar and the Listerin was very different. The reasoning behind all of this is because the alcohol in the Listerin, the ethanol, kills almost all the bacteria in the mouth, despite it even being helpful bacteria. The non-alcoholic mouthwashes only use cetisperidium chloride, which targets only the bad bacteria. So why Listerin kills more bacteria.
And these are references, and boom, that is the chemistry of mouthwash.
Bill Nye the Science Guy. Bill Nye the Science Guy.
Science rules.
Bill Nye the Science Guy.
Inertia is a property of matter. T minus 7 seconds.
Bill Nye the Science Guy.
Alright guys, it is time for us to start our experiment by testing the effectiveness of alcohol mouthwash and non-alcohol mouthwash. But first, we need to disinfect the table that we're going to be using to experiment this. So we gotta clean everywhere. We want to make sure that there's no germs and stuff that could ruin this experiment because that would affect the effectiveness of it. Okay, the table is very clean now. Time to dispose the trash.
Puts it up. Bang! Jeremy
Tell
Lin.
everyone to put gloves on. I don't want to put dirty hands on everything because that is bad for the experiment also. Okay guys, in order to be fully safe, we have to make sure everything is clean. We have to clean each other's gloves. Kevin, put your hands up. And I'll also clean my hands too. Oh, my bad, Kevin. We were done with this part. You're putting this stuff in each other's mouths. Open your mouth, Kevin. Guys, say your names.
I'm Emily.
I'm Jane.
Yeah, these are test subjects.
Oh, these test subjects are gonna swab their mouths so they can get a control sample of the bacteria.
Hi.
Do it on your tongue. You can go put in the petri dish.
So careful.
Don't rip it.
Good.
Yeah, it's probably fine.
Okay. Here.
Yeah, and then we're gonna put it here. We are dumping the mouthwash in the cups to get ready for these people to put it in their mouth. So we are gonna be swishing this thing in our mouth for 30 seconds. And his says 30 seconds too, just trust.
Swish, and after 30 seconds, you spit, and then you swallow.
So
3, 2, 1.
make sure to goggle really good. There's Miss Mix too. Alright.
Okay, 5 more seconds. Can I get this?
Oh, fuck, it hurts.
Alright guys,
Why do you use so much?
now it's time to swab.
Oh, burn.
You good?
Oh, that was.
Okay.
Did I read it?
Yeah.
It would have been, that's a bit closer comfort. It was okay.
How do you rate the taste of yours?
I feel like it was like a solid 5 out of 10, but I feel like if we had used less of it, it would have probably been more ideal.
Over here, this man, Kevin Hennet, is putting paraffin on a thing so like stuff doesn't get leaked out and no one will have some crazy bacteria virus thing that we created in the lab. Alright, now we're gonna put our experiment into the incubator and it is at 37 degrees and we will wait for them on Monday to see the results of our experiment. And now we wait. Alright guys, it's been 3 days since we last checked on our samples. Let's go see how they are. Kevin's gonna take all of them out and place them on these tables.
I'm coming back.
Alright, so right here we have our control sample and then we have the alcohol sample. And these are the non-alcohol samples. Right here.
Under control.
Yep. Ben, what do you think of the table of facts?
Someday these will be the good old days. All the love you forget.
Yeah, Cal, where's
And all
the
these
control, bro?
reckless nights you
You want to see it?
Your whole life's gonna change. You'll miss the magic of these girls.
I was thinking about the band. I was thinking about the fans. We were underground, loading merch in that 12-passenger van in a small club in Minnesota, and the snow outside of First Ave. I just wanted my name in a star. Now look at where we at, still growing up, still growing up. I would lay in my bed and dream about what I'd become. Couldn't wait to get older, couldn't wait to be some. Now that I'm here, wishing I was still young. Those good old days.
I wish somebody would've told me, babe, that someday these would be the good old days. All the love you won't forget, and all these reckless nights you won't regret. 'Cause someday soon your whole life's gonna change. You'll miss the magic of the good old days.
Wish I didn't think I had the answers. Wish I didn't drink all of that glass first. Wish I made it to homecoming, got up the courage to ask her. Wish I would've gotten out of my shell. Wish I put the bottle back on that shelf. Wish I wouldn't have worried about what other people thought and felt comfortable with myself. Rooftop open, and the stars above. Moment frozen, sneaking out and falling in love. Me, you, and that futon, we just begun. On the grass dreaming, figuring out who I was. Those good old days.
Could've told me, babe, that someday these would be the good old days. Reckless nights you won't regret. 'Cause someday soon your whole life's gonna change. You'll miss the magic of the good old days.
Never thought we'd get old. Maybe we're still young. Maybe you always look back and think it was better than it was. Maybe these are the moments. Maybe I've been missing what it's about. Been scared of the future, thinking about the past while missing out on now. We've come so far, I guess I'm proud. And I ain't worried about the wrinkles around my smile. I got some scars, I've been around. I felt some pain, I've seen some things, but I'm here now. Those good old days.
You don't know what you got till you got away. Tell me why till nothing but a heart. Nothing but a